So this is a case study of an example where we have a SmARTvar on a number of marine platforms located in the Gulf of Mexico. And a little bit difficult to see, but here's the power system. There are 3 generators in this case as power sources, and a number of motors being operated by the SCR phase control motor controllers. The problem here is that the power factor on this system was 0.6 inductive at the input side of those SCR controllers or DC motor drives. There was an excessive kVA demand based on the generation capability. The typical demand of 18 kilowatts with a power factor of 0.6 required 3,000 kVA or 3 MVA of generation. So 2.7 MVA generators were required to supply this load, even though it was only 1,800 kilowatts. And on occasion, a third diesel-based generator had to be started to fully operate those loads. The load in this case are well perforation motors, oil pumping motors, motors for cranes on the platform. And the demand varied from about 40% to 100% load in as little as 1 second. So it was a dynamic operation that needed to be compensated. The customer objectives in this case were to maintain nearly 1.0 or unity power factor under all of the various operating conditions and loads. Customer objective was to achieve and maintain a voltage distortion that was 5% or less, and to maintain current distortion less than 12%. So based on those customer objectives, our engineers looked at the load profile situation and made a recommendation. Another point of interest is that this has proven over time to be a very difficult application. In fact, the customer in this case had 11 pieces of a competitor's thyristor switch product which were not working, and the reason they were not working was due to these notches in the voltage waveform, which are present because of the SCR motor controls for the DC motors. So these notches represent a false zero cross and was interfering with the other more traditional type thyristor switches. So our solution was an 1800 kVAR SmARTvar, 600 volt class, 50 hertz. This is a thyristor switch with the new SmARTvar switch, and we compensated the system with both a 5th and 7th harmonic filter, because the customer's objective was to not only achieve the high power factor but also to reduce harmonics. The 2 most significant harmonics in this case were 5th and 7th, so we designed this to provide the kVARs for capacitor or for power factor improvement, as well as harmonic filtering. The attributes of this product were first that it had a very high speed controller or extra rapid controller which can take 10,000 measurements per second. It utilized our zero cross thyristor switching mechanism or system, offered transient free capacitor switching, and rapid switching of the complete capacitor system in typically 8 to about 11 milliseconds. So the initial conditions were this voltage waveform with the red with the very high potential notches. And here we see the voltage distortion with about 14.8% total harmonic voltage distortion on the system. The objective again was 5%. The current distortion here is 19%, and we see that the 5th harmonic is the richest with the 7th being next, and again here the 5th harmonic and 7th harmonic are the 2 richest harmonics in the system. So now the results after we applied the SmARTvar system is that the voltage notches are reduced to very low levels so that they are far away from the zero axis. So they no longer provide any danger of switching or providing a false signal to other equipment. And the harmonic spectrum is such that now the voltage distortion is only 3.3%. The objective was 5, so the objective was obtained here. The current distortion is only 11.7%. The objective was 12, so again, the objective was met. And current distortion could be further reduced if the customer needed this. In this case, we only reduce to the level that the customer, low enough to meet the customer objective, because any further reduction would cost more money and would extend the payback period. So current distortion is now reduced to less than 12%, instead of 57, and only about 5 and 7% each. So we have a much better voltage waveform and a much better current waveform than what we saw there.
That's cute, huh?
These are just some interesting photographs from the job site in this case. Here are the gentlemen, how they are brought up onto the drilling platform itself.